Welcome back to another short Ramda JS video, and in this video we are going to talk about the function defaultTo. And let's just start by reading the definition, right? Because this is probably pretty simple. So defaultTo returns the second argument if the second argument is not null, undefined, or nan. So nan is not a number, right? Otherwise, the first argument is returned. Okay, so it returns the second argument if this second argument isn't null or undefined or nan. So if we have a second argument, quotation marks have, if we have a second argument, it returns the second argument. But if we don't, then we get the first argument. So if you think about it, it's kind of like the implementation. Let's just jump into Node here. It's kind of like the implementation of OR in JavaScript, if I'm not mistaken. Maybe I'm mistaken here, but let's think about this. So usually people do something like this, right? Where they say, let's say that you have a variable x and it might contain undefined. So let's say that x is undefined, right? And then we would say x or hello. Yeah, so then we get hello. But if x is not undefined, so let's put the string world, right? Then if we say x or hello, we get world, right? It's completely stumped. Yeah. So this is expected behavior, right? I mean, so if you think about it, that's people tend to, in many different languages, such as, for example, JavaScript, and I think Ruby has something equivalent to this, right? Where it's like it's called something like a short circuit or something like this. No, actually, I'm thinking of a different thing. I'm thinking of this operator in Ruby, but never mind. You can do this in a number of languages, right? So the return value of A or B in JavaScript, I guess is actually, let's think about it. If we had x if we have, actually, let me just say A or undefined, hello, undefined, then we get A. And if we have undefined or A, I was actually expecting more weirdness, but we don't have more weirdness. That actually surprises me massively, right? So in both of these cases, because we have undefined in one of these ends, we get the other end, which is the value. Or I mean, let me be more specific. Or is a binary operation that takes two arguments, and in case of one of the arguments, if one of the arguments is falsy, right? Because it's not necessarily false, it's just falsy, then we return the other value. And okay, right, and that value would be truthy. Of course, we can't just say undefined or 0. Oh, actually we could, but then this would be equal to false, I guess, because this whole thing is falsy, but we still get that value back. So that was a bit surprising, right? It's like, so what about 0 or undefined? Yeah, then we get undefined, right? So 0 is falsy and undefined is falsy. So in the case that both of these are false, then we get the second argument. We get that argument back, because these could potentially be two different things, but both of them are falsy. So JavaScript needs to determine whether it should return this or false strictly, right? I mean, another implementation of this would be that it would just return false. That would be a valid implementation. In terms of how JavaScript is written, but of course, I guess the reason that they've chosen to define it this way, so that 0 or undefined behaves differently from undefined or 0, is that you want to be able to do this kind of thing, where you say, well, okay, either I want to have the value of x or I want to have the string hello, right? So the reason I'm saying that is that this is the native way in JavaScript to do default, right? defaultTo. And probably because then this operator isn't partially applicable, right? I mean, it isn't curried. So then we need a different way when we want to curry functions to have a curryable, a partially applicable version of this operator, of defaultTo. So then hence we have Ramda's defaultTo. So let's say require Ramda, like that, let's say, do we have defaultTo? Oops, sorry, defaultTo. Yes, okay. So if we say defaultTo hello, then we should get back a function. Let's say let f be R.defaultTo hello. then that means that if we run f on undefined, then we should get hello. But if we run f on world, then we should get world, right? Because if we supply it a value that is truthy, we get back the value that we supplied it. But if we supply it a value that is falsy, then we get back the value that it has been loaded with in its default to-ness, right? I mean, we get the first argument essentially, right? So I mean, if I don't express this in any strange way, we could just say default to. So we default to hello if in the absence of a second argument, like if this is undefined, then we get hello. But if this is not undefined, right? Not undefined. So the string not undefined is clearly not defined. Sorry, it's clearly not undefined. Well, that makes no sense. Actually, maybe I should just say defined. so that string is defined, so it's truthy. So hence we get that thing back instead. And yeah, I mean, I guess there's sort of nothing more to it. Let's look at this, right? Let's look at their example to see if there's something interesting that we're missing. So you can default to null. And then in the case, no wait, sorry, they're declaring the function default to 42, so that in case, yeah, so the first argument is 42, so that if you, okay, so which is probably like Hitchhiker's Guide to the Hitchhiker's Guide to the Galaxy, right? Like the answer to all questions or something like that. But anyway, so in absence of a second argument, return 42, right? So if you run default to 42 on null, you get 42. If you run it on undefined, you get 42. But if you run it on Ramda, then of course you get Ramda back because Ramda is defined. What is this? Parse int string. Yeah, okay, here's just a comment that emphasizes that if you parse int on the string, like on the string that says string, then you get not a number, right? I mean, we can just show this by saying if you say parse int, I mean, that's a native JavaScript function. And if you parse hello, then you get not a number, right? I wonder if I can construct, yeah, I can construct not a number like that as well, right? So if we would say R.defaultTo, we're defaulting to hello by parse int foo, right? Actually, maybe I should put here not a number. I mean, it's a string. And then we get hello. So probably the way you could probably use this is something like, let's say that you have user input, right? So let's say we have a variable user. Yeah, let's say username that's sort of coming from a field or something like that. Sorry, not username. Yeah, but age makes no sense. But let's say day, right? Like day that comes from a field, right? So let's say if this day is, I mean, since it's a field, yes, let's say that it's not 0 indexed, because otherwise we're not going to get, yeah, because 0 is, actually, wait, that's interesting. Sorry. Default, how about this? Default to hello given 0. Do we get hello or we get 0? Oh, okay, so 0 is actually okay. 0 is not, so sorry, I was saying falsy. But it's not actually falsy, right? It's not, and then that's probably why they're not saying falsy. They actually explicitly mean null, undefined, or nan, right? So let's say false. Yeah, sorry, I was wrong. It's not falsy, okay? It's an implementation which is similar to or, but it's not exactly or. They're explicitly checking for null, undefined, or nan. So false counts as a value and 0 counts as a value. So it's not falsy. Apologies for that. So that means that you can do stuff like, let's say you have a user input, which is supposed to be a number, right? But you get it as a string, right? So let's say it contains some spaces, because I think you can parse that, right? Like let's say we have that. So can we say parse int user input? Yeah, then we get the number 12, right? But if user input was, if we had like user input is 12x, then we can't say parse int user input. Oh, actually we can. That's interesting. Okay, so JavaScript is about this. Okay, it's very interesting, right? So JavaScript is actually trying to find a number in this string. What if I put x here? No, so then we get another number, right? So like it seems that the parse int function is sort of identifying the first number in a string by first trimming spaces and then assuming that the next character is a number. But if we start with a character that's not a number, then it turns out then it spits out not a number, right? So the way we can actually very, very usefully use the function default to is that we could say, well, I want to default to, for example, 0. I mean, depends on what kind of user input you're talking about and what kind of default makes sense for your scenario. So you would say default to 0, for example, and then say parse int of the user input, right? Makes sense. And then you get 0 because now the user passed this strange input, like the variable was this. But if the user input was 12, let's say, then if we do this thing again, of course we get 12 back. And of course, again, like we have this, all this power of function composition and partial applications. So you can simply say default to 0 and then stick this into a pipeline, right? So you would say something like R.pipe parse int. I'm not sure if you can, yeah, we probably can use that. First parse the int and then default that to 0, right? So this gives us a function. So let's say f, and this is like the input sanitizer, right? Our default is not a function. Oh, sorry, default to, our default to. So then we have the function f, and now we can call f on some arbitrary user input, such as 1, 2, 3. Then we get 1, 2, 3. But if we call it on x 1, 2, 3, we get the default value, which is 0, right? So that's actually like pretty useful, like seriously pretty useful. And of course, in this pipeline, you would probably stick other like validation logic or something like that. So pretty useful function for sure. Let's just see, can we trivially define this ourselves? What if we would say, so let me just use f again. So f, how would I define default to? So if it's not, I mean, it's probably very trivial. It's like you get an x and you get a y, and if y, so if y is not null and y is not undefined and y is not nan, yeah, then y else x. This should be the implementation, right? So ooh, now I overwrote f. Let's actually, sorry, let's do this. I'm using f too many times. No, but whatever. I mean, let's do it this way. So let's say f is our new default to. So I default to hello in the absence of another value. So if I pass not a number, then I should get hello. No, I got not a number. What am I doing wrong? If y is not null and it is not undefined and it is not nan, then y. Root? I am so confused. Maybe you can't check for nan like this, right? I mean, I can construct nan. Can I say, yeah, so that makes no sense, right? What is that? Is it something like, is nan? Yes, okay, sorry, that's the way you should do it. Foo? Yeah. Okay, interesting. So actually the implementation should be something like this. So JavaScript, man, I don't know. Is nan y? So if y is not. So if y is not null, it's not undefined, and it's not nan, then we return y. Otherwise we return x. Let's try that again. Let's run this stuff. So default to hello, and then we give it nan. Yeah, then we get hello. And now let's see if this works. So, but if we give it world, oof, what did I do wrong? If it's not, so let's let's just check this out. World is not undefined. That's what we're checking, right? But undefined is not undefined is false. Of course, that's true, right? And world is not null. That's true, right? So okay, so the condition that we have here is that we're passing in world, and we're saying world is not, I'm just typing it out, right, to be explicit. It's not null, and world is not undefined, and world, not is nan world. And what would I expect? I would expect to get true here. Wait. Yes. Is nan like that? Okay, but I get false. So wait, is nan of world. Right, gives me true, but then I'm flipping that to false. So if it's nan, wait. Okay, sorry, now I'm super confused. If it's not a number, should I just flip this? I'm so confused. So this throws me off. I could just flip this whole thing to an or, and that would make perfect sense. But we're saying that so a string that's not a number will in terms of is nan return true, and I want to check whether that's, yeah, I mean, wait, I mean, maybe this is too strong. So it's like, I mean, is nan of world, right, sorry, because we explicitly want to check for nan. So yeah, this is problematic. So we need to actually be able to check for like equals nan. But I mean, okay, instead of figuring out how to do that, shouldn't it be possible just to flip this? I mean, if we say this instead, right? If we implement f like this, if y is null, or let me just retype this. If y is null, or y is undefined, or is nan y. Maybe this helps, right? Then x, otherwise y. Let's try that, right? Hello, and then world. World is, sorry, string world. Okay, then we get hello, which is wrong. It's probably definitely this is nan thing that's messing us up, right? Because this works, but then if I pass undefined, I get hello, and if I pass null, we get hello. But if we pass foo, or I mean, let's say world, then we get world. Okay, so it's definitely this is nan thing. So sorry, instead of trying to solve this on camera, let's actually check what their implementation is to see how they are, I like to save time for both of us. So they are saying, okay, v, if it's equal to, oh, it's very interesting. Okay, if v is null, but then they return true? That makes no sense. So they're using this or thing that we were talking about in JavaScript, right? Where they're saying like the value that you get where world is equal to null, that would give us false, or world is strictly not equal to what? V, then they're checking truthiness. Smart, okay. So, world, wait, what? V is strictly not equal to V? I am so confused. World is strictly not equal to world. What? Because, ooh, that was smart. Nan is strict. No, wait. So let's try. So parse int something that gives us. So parse int foo gives us nan. Is that strictly not equal to parse int foo? Wait, sorry, parenthesis. Strictly not equal to foo. That is pretty funny. Which means so like this is probably like a serious edge case of JavaScript where it's like, why in the world would nan not be strictly equal to nan? That just like in my mind kind of makes no sense. But maybe, I mean, maybe you could argue that it makes sense because it's like it's a different point in memory that represents something that's not a number, but it's still different. But so, I mean, how often do you see this? Like v is not equal to v, like strictly not equal to v. That like for sure makes no sense. So if that's the case, then you should give the default value back, but otherwise you should give v back. So if v is null, then we would be returning true. That kind of confuses me as well. So then it's like, well, I mean, foo equals null just gives false. So if that's false, then we're jumping into the other branch. But if we have null, it's equal to null, that's true. And if we have undefined equal to null, that's also true. Okay, so this captures undefined and it captures undefined and it captures and null. Sorry, I got a bit thrown off. But then again, like that just gives us true. So then it's like true, or then we have something else there, foo. So it's like, I mean, null is equal to, right. Null is equal to v. So if v is null, then we get that. So or let's say foo here. No, then we still get true. It's totally confusing. Why in the world? I mean, let's just try this. We'll just copy this and just define that here. Oh, yeah. Copy. Paste. Okay, default to foo given bar. But that just doesn't work. Wait, what? No, sorry. Of course, that's correct. My bad. Default to foo when passed undefined, then you get foo. Okay, so of course it works, right? But I'm just totally confused about the role that this thing plays. The default value will be returned. The second value, if it is not null, undefined, or nan, otherwise the default value. So how could... So it's like we have, in the above case, right? We have foo equals null, or foo strictly not equals to foo. Actually, let me put this in a variable. Let's just do this. Let d be foo, and let v be bar, right? So we're trying to figure this out. So v is equal to null, or v strictly not equal to v, then d or v. Okay, and that gives us bar because no. V is, okay. So because the default is foo and the value is bar, but because the value is defined, then we don't have to return the default, but we return the value. But if v was null and we ran this again, then we get foo. Okay, so clearly like this implementation works. It's just like it's confusing because, so let's just see, let's say that we return the other here, right? The other branch. Then we get true. Like, why does that even change anything? Am I getting the order of execution wrong here? Like, is it like null or... Maybe I'm getting that wrong. It's like null or... Wait. Let me throw some parentheses in here. So the way I would read this is like this. Right? Like this and like this. Oops. No, sorry. Like this. So then that gives us foo, which is our default, right? Hang on. Our default is this, and our value is null. Yeah. So we get the default, which is the correct implementation. And what if our value was bar? Then like we have, so the default is foo and the value is bar, so we have a value, so we should get back the value, and then we get back bar, right? So I'm not getting the order of execution wrong. Like this is actually the way it seems to work. But maybe if we throw in one more parenthesis, like, so I would also interpret it as this. Wait. sorry, this, we still get bar. Debugging live on camera. Okay, why would this be? So what confuses me is very much is that the other branch is that if I just if v is null, sorry, now v is bar. Okay, sorry, this is the short circuiting. Sorry, this is why I'm not understanding. If the first branch is false, then we start why am I being so confused, right? Because so if the first branch is false, then we start executing the second branch. But if the first, right, but maybe that's not the confusing part, right? Because then we would just return the second branch. But if the first branch turns out to be true, right? Like if we have true here, and then we have or, but that's also maybe what we said in the beginning, right? Like let's go way back to the beginning. We were talking about if you have a and yeah, I mean, we were talking about it, but let's just do it again. Like if you had foo or bar, no, you get foo, you get the first one, right? But in the case of undefined, like if you had undefined or null, then you get the second one. And if you have null or undefined, then you also get the second one. But if you have two things that are true, then it's short-circuited, so you get back the first thing that's true. That's evaluating to true, right? So v equals null. I mean, if the value is bar, yeah, then we get back false, right? But if the value is null, then v equals null should give us true. So then that would be short-circuited, and what we should get back is true, right? I mean, that just confuses me a ton. So let's say, I mean, we have, this is a can of worms really that I opened here, right? I mean, if we remove all of these parentheses, so, or maybe actually let's keep this one. No, whatever, let's just remove these. We've established that our assumptions there were true. So why do we not get true here, right? I mean, v so again, sorry, v is null, right? V is equal to null, and we run this, and I'm confused about why we're not getting true back. If I put something here, then we get true back, right? So it's not truly short-circuited. I think surely this is the moment where we have to look at the OR operator of JavaScript. Hang on, so logical operators. Sorry about all this debugging. Sorry, so I just opened up a window and I'm searching for the logical operator OR, right? Logical operators are typically used with Boolean logical values. When they return a Boolean value. However, and or operators actually return the value of one of the specified operands. So if these operands are used with non-Boolean values, they may return a non-Boolean value. The logical operators are described in the following table. Okay, so logical OR returns expression 1 if it can be converted to true. Otherwise returns expression 2. So if the first expression can be converted to true, supposedly it then returns that. But I mean, clearly we're seeing that it doesn't. I'm so confused, right? Because here it doesn't. Like, let me just say D and V here. I mean, we end up with D, right? We end up here because we are evaluating this particular expression. So the question is, like, what can I put here? Like, can I put like v equals v? Oh, sorry, actually v equals v is true. So foo, otherwise bar. Yeah, we're still ending up here. But if I just put v here, for example, when v is null, we're actually getting this value. This or this. Yeah, because this one, yeah, but I mean, now it's funny because v is null, right? So then this is actually false. But if I return not v, for example, yeah, okay, that's difficult to tell, because what is not v? Like not v, yeah, not v is true. Can I just say toString? Like not v to string? No. Okay. Wait, toString? Yeah, okay, I mean, fine. That just gives us something else. toString. Yeah, so we still end up here, but somehow, like when we start to do a comparison, it just shifts, right? Thus, when used with Boolean values, or returns true if either operand is true. If both, by the way, like if this is completely uninteresting to you, apologies. Cut the video here, and I'll see you in the next one. Super good. Thanks a ton for watching. I think you understand how to use defaultTo, R.defaultTo. But let's figure this out. Let's get to the bottom of this for the rest of you. Thus, when used with Boolean values, or returns true if either operand is true. If both are false, returns false. Okay, so no, but this is like when used with Boolean values. No, actually, yes. When used with Boolean values, or returns true if either operand is true. If both are false, returns false. But it's not actually saying what it does if we're mixing. Like, so the first one is a Boolean value, right? Because the first one is a Boolean value, and then the second one is an expression. I mean, it seems to me that that's what's changing, right? Like if we say v equals null, yeah, I mean anything, right? Like v equals v, then a otherwise b, right? Then we're gonna end up in the second one. But if we don't have an expression here, not expression, then we end up in the first branch. That is so funny to me. Because I mean, clearly this thing is truthy. Is true. No, sorry. It's okay. Well, how do I not expression or foo? I mean, it's truthy, right? You get not expression. Yeah, I don't actually know what to. Examples of expressions that can be converted to false are those that evaluate to null, 0, nan, the empty string, undefined. The following code shows examples of. Wait, here is maybe if I have no. Oh, it's so like I don't understand. I mean, because so this is totally expected, right? Because then we have false on this side, so hence we're evaluating this side. But we have a case where we have true on this side, but we're actually still evaluating the right-hand side. So it should be short-circuited. Yeah, so here, right? I mean, as logical expressions that are evaluated left to right, they are tested for possible short-circuit evaluation using the following rules. False and anything is short-circuited to short-circuit evaluated to false. So you're not evaluating anything here. True or anything is short-circuit evaluated to true. But that's, I mean, clearly that's not true, right? We're just seeing a case of where that's not true. So it's like, let's make this simpler. Does 1 equal, well, like, okay, let's clear this. Does 1 equal 1? That's true, right? So if 1 equals 1, okay, or 2, or actually 1 equals 1, or yeah, then A, otherwise B. Then we get A, right? So I mean, let's even simplify this even more. If we have true here, and we have true here, then we still get A. So supposedly this should be short-circuited, right? Because the first argument here is true, but which it is, right? If I say foo here, we will get true back. So then we know that then it's short-circuited. But in the existence of an expression on this side, that's not the case. And then the question is, what kind of, like, is it only, what is this, like the ternary operator? Is it only, let's search here, ternary, conditional ternary operator. But maybe that's just a, Has both binary and unary operators and one special ternary operator. No, but I mean ternary, that's probably just, yeah, it's just this thing. So I'm debating whether I should just cut this off and search for this offline, and we'll talk about this in another video. Let's check it. I mean, we're at 30 minutes, so probably that's a better idea. And then we will just yeah, I'll figure this out, and then we'll talk about this some other time. But it's like ternary operator and or in JavaScript. Like there's some, sorry, I'm just doing a quick, let's do a quick Google here, right? Like frequently used as a sorry, I accidentally clicked this. Let's just quickly see if we can find the answer here. Like ternary operator, yeah, I should do this offline. Param. Yeah, maybe we do it something like this, like so or not short circuited ternary operator JavaScript. But I don't actually need just the ternary operator. I mean, right? Like, could we do, like, if we say foo or bar, let's say. No, so it's like, it seems to be explicitly the ternary operator. Ternary operator in binary. No. Okay, last one, and then we'll cut it. So, ternary. Yeah, this is just bonkers to me. Okay, anyways, I'll cut it here. Sorry. If you know why this is, I should have cut it from the beginning. Sorry, I'm learning from my mistakes. Next time I will cut the video as soon as I realize that I have no idea. If you know how to or why this is, please do shoot something in the comments. And if nobody has commented until I've managed to figure it out, then I will post something in the comment section that explains why this is. Because clearly this was a very, very interesting behavior of JavaScript that in some sense is strictly opposed to this statement in the documentation where they say, in regards to short-circuiting, where they say that this statement is short-circuited to be evaluated to true if the left-hand side is true, because clearly we are seeing an example of where this is not the case, right? Because the left-hand side is clearly true, but we're still actually evaluating the right-hand side. So yeah, if you know why that is, please do shoot something in the comments. Sorry about this very long video. And again, I mean, we do know how to use the Ramda JS anyways. I mean, that you definitely know. And yes, I will see you in the next one. Thanks a ton for watching.